Assalamualaikum and hi guys. So let us continue for the next subtopic, properties of the Laplace transform. So there are three properties of the Laplace transform. The first one is linearity, the second one is the first shift theorem, the third one is the multiplying by Tn. So for the first properties, we will learn about the linearity properties. So you can refer to the textbook Theorem 4.1 page 133. Theorem 4.1 linear property. If Laplace ft and Laplace gt are exist, and if alpha and beta are constant means that alpha and beta is any number, then Laplace, the whole thing in the curly bracket, alpha multiply ft plus beta multiply gt is equal to alpha Laplace ft plus beta Laplace gt and is equal to alpha fs plus beta gs. So what does it mean by the linearity properties? If you have Laplace in the curly bracket, you have a constant inside the curly bracket, the constant can be moved to the outside. So that is why your alpha here and your beta here is outside the bracket. So Laplace ft will become fs. Laplace gt will become gs. So that is what we mean by the linearity properties. Okay, let us continue with the example. So this example I take from exercise 4.2 page 134. Find the Laplace transform for the following functions. So the function that you have here is 5t the power of 3 plus 6t. Okay, so we want to find the Laplace transform for this function. Okay, so to find the Laplace transform, you have to put the notation of the Laplace ft is equal to Laplace 5t the power of 3 plus 6t. Okay, so the whole thing, the whole ft is inside the curly bracket. So now we want to apply the linearity properties. How could we know that you have to apply the linearity? Because you have one function plus another function here. Okay, you have the operation plus here. So that's why you should know that if you have plus or minus operation, you have to apply the linearity properties. So now you have to separate the function. You have plus in the middle here, means that you have to break out the Laplace transform notation. So Laplace 5t the power of 3 plus Laplace 6t. Okay, so now we have separate. It's become two Laplace notation now. Okay, so if you have any constant, you have to bring the constant to the outside. Okay, so for this one, you have to bring 5 to the outside, and for this one, you have to bring 6 to the outside. Outside in front of the Laplace notation. So 5 Laplace t the power of 3 plus 6 Laplace t. So now you have to refer to the table of the Laplace transform. Okay, so you have to check Laplace t the power of 3. You have to transform it become what? Laplace t when you transform it become what? So you have to refer to the table of the Laplace transform. Okay, now refer to the table of the Laplace transform. Laplace t the power of 3, you must refer to the function that you have t the power of n. So this is t the power of n, and the answer will become n factorial over s the power of n plus 1. So you have to determine what is the value of n for the Laplace t the power of 3. So this one, n is equal to 3. For the Laplace t, so what is our n here? So this one, n is equal to 1. So now write our answer based on this Laplace transform. So it's equal 5 multiply n factorial. So you have to substitute our n here. So our n is equal to 3. 3 factorial over s to the power of n plus 1. S the power of 3 plus 1 plus, for the second Laplace transform, 6 Laplace t. Our n is equal to 1. 6 multiply 1 factorial over s1 plus 1. So now you have to simplify any number that you can multiply, which is 5 multiply with the 3 factorial, 6 multiply with the 1 factorial. So 5 multiply with the 3 factorial, the answer will become 30 over s. 3 plus 1 will become 4 plus 6 multiply with the 1 factorial, 6 over s the power of 2. So this is the answer for the Laplace transform for the question A. For next example, find the Laplace transform for the 2t the power of 4 minus exponent negative 4t. So we can see here, you have minus operation between the first function and the second function. So we should know that you have to apply the linearity properties. So the first step, you have to write the Laplace ft is equal to the, we already know that the constant 2 we can bring to the outside of the notation of the Laplace. So we can directly write 2 at the outside, Laplace t the power of 4 minus, for the second one here, you don't have any constant that you can bring to the outside, so means that there is no constant at the outside, minus Laplace exponent negative 4t. Okay, so now you have to refer to the table of the Laplace transform. So Laplace t the power of 4, you have to refer to the t the power of n. Laplace exponent negative 4t, you have to refer to the table of the Laplace exponent at. Okay, by refer to the table of the Laplace transform, Laplace t the power of 4, you have to refer to the t the power of n. So you have to determine what is the value of n. So our n is equal to 4, and for the Laplace exponent negative 4t, you have to refer to the exponent a t. So we have to determine what is the value of a. So our a is equal to the negative 4. So now we can write our answer. 2 multiply with the Laplace t the power of 4, which means 2 multiply with the n factorial divide with s the power of n plus 1. So n is equal to 4. So 4 factorial divide with s4 plus 1. Minus with minus Laplace exponent negative 4t. So we have determined our a is equal to negative 4. So our answer for the Laplace exponent at is 1 over s minus a. So therefore, minus 1 over s minus minus 4. So now you have to simplify the answer. 2 multiply with the 4 factorial will become 48 over s the power of 4 plus 1, which is 5, plus 1 over s minus minus 4. So minus minus 4 will become s plus 4. So this is our answer for the Laplace transform example B. Okay, for next example, example C, you have 1 minus exponent negative t, in the bracket you have power 2. So if you have any function in terms of bracket here and you have power at the outside, you have to expand first. So how to expand the function? You have to make it in terms of 2 bracket. 1 minus exponent negative t, 1 minus exponent negative t. So now expand the function. 1 multiply with 1 will become 1. 1 multiply with the exponent negative t will become negative exponent negative t. Negative exponent negative t multiply with 1 will become negative exponent negative t. Exponent negative t multiply with the exponent negative t, negative and negative will become positive. Exponent negative multiply with the exponent negative. So this one is exponent negative t multiply exponent negative t. So what should you do with this power? Okay, so you have to plus the power. So this one will become exponent negative 2t. So this one will become plus exponent negative 2t. So if you have anything that you can simplify, you have to simplify, which is negative exponent negative t minus exponent negative t. You can simplify, which is negative and negative here will become negative 2. 1 minus 2 exponent negative t plus exponent negative 2t. So this step, we only expand the function. We are not finding yet the Laplace transform. So now how to find the Laplace transform? You have to write the symbol or notation of the Laplace for every single term. You have 1, 2 and 3 terms here. Okay. So therefore, Laplace for ft is equal to Laplace of 1 minus 2 at the outside because 2 is a constant. 2 Laplace exponent negative t plus, this one you don't have any constant, plus Laplace exponent negative 2t. Okay, so from here you have to refer to the table of the Laplace transform. By referring to the table of the Laplace transform, Laplace 1, which is Laplace a, will become a over s. So this one will become 1 over s because our a is equal to 1. So for the negative 2, Laplace exponent negative t, we refer to the exponent at. Our a is equal to negative 1. A is equal to negative 1. So therefore, the answer will become 1 divided with s minus a minus 2 multiply with 1 over s minus 1 plus Laplace of the exponent negative 2t. Our a here is equal to negative 2. A is equal to negative 2. So therefore, Laplace of exponent negative 2 will become 1 over s minus a. 1 over s minus 2. Okay, now you have to simplify the negative sign. 1 over s minus 2 can be multiplied inside, will become 2 over s minus 1 will become s plus 1 plus with 1 over s minus 2. So minus 2 will become plus 1 over s plus 2. So this is the final answer for the Laplace transform example C.